Hello, I'm Romulo, and I will talk about how the analysis complexity and the lack of standardization is affecting the finding of general trends in ecology. This is a case study from a meta-analysis that I performed during my PhD. Add some context. Meta-analysis is a set of statistical methods for combining the magnitudes of the outcomes across different datasets addressing the same research question. And the more studies available, better is the prediction of the general effect, and the use of meta-analysis in ecology is exponentially growing. There are some ways of summarizing multiple studies in a general effect. One of them is the comparison of means using the HGG value. This is the one I used in my meta-analysis. The HGG quantifies the difference between means of two groups, and I also can convert correlation parameters into HGG. After the calculation of HSG, the next step is to perform the model that computes the general effect size. For this, it is important to have comparable means between the studies. By doing it, my objective was to find general effects on how human activities are changing freshwater fish functional diversity. Functional diversity is a measure of diversity based on organisms' traits. These traits might be related to different aspects of fish ecology, and they are used to measure difference between species to ordinate them in a functional space through a factorial analysis, from where we calculate different components of diversity. There are three major components that can be measured in the functional diversity: the functional richness, divergence, and regularity, and they are related to the range of traits of that community, the distance between the traits, and the regularity of their distributions. So, I gather studies that measure functional diversity both on natural and impacted places, and I extracted the information needed to perform the meta-analysis. The work was published on Ecography in 2025. And there we find that functional diversity, especially richness and regularity, is being reduced on tropics. I had two types of articles: those that compared the functional diversity between natural and impacted sites through means, and others that used linear regressions. For the first type, I extract the mean, error, and sample size for both groups, impacted and natural, and for the second type, I extract the correlation coefficient and the sample size. Each comparison between means or a correlation coefficient was an observation, and these observations varied in terms of climate region, if it was on temperate or tropical areas, the functional component, if it measured the richness, the regularity or divergence, and the human activity, if it was a pollution that was being studied, the construction of dams, disconnectivity, invasion, habitat homogenization, or deforestation. My search gathered 1,129 articles. After excluding duplicates, I ended up with 804 articles, from which I screened the title and abstracts to select the papers that evaluated change in functional indices due to human activities in fresh waters and fish communities. After this screen, I ended up with 116 articles, from which I excluded 69 due to different reasons and used 41 in my meta-analysis. Here, I want to focus on the 28 studies that asked a question similar to mine, but that I needed to exclude because of bad data reporting or that used different analyses to answer the same question. From these 28 studies, 11 used analyses that are more complex to use in this meta-analysis, such as multiple regressions or pathway models. 9 used the functional ecology background, but with a slightly different question. Rather than calculate functional indices, 3 calculate beta diversity, and 6 describe changes in trait composition without calculating indices. And 8 papers incompletely reported the data. After excluding those papers, I ended up with 41 studies and 178 observations. But you may ask, aren't 41 studies good enough? Yeah, it is, but they present a lot of variability across them, reducing the number of replicas that evaluate the same thing. For example, as you can see in the last two lines of the table, the total observations is divided by the climate, the type of impact, and the functional component measured. So, the addition of the 28 studies might have resulted into better filling each categories, which would allow us to ask more questions. For example, the low number of observations refrained us from answering some of the reviewers' questions. They asked us to test differences of the water bottle system or the system size, or to test the difference between temporal or spatial studies, but had few observations to do so. But we managed to test one of the requests that was to test how the number of traits influence the effect size. And we managed to do it at least superficially because deforestation had a lot of replicas, as we can see here in this table. Summarizing, we understand that the lack of patronization between studies and the complexity of analysis choosing are reducing the number of comparable research, and gladly, few studies badly reported their findings, although they represent 20% of the total number of studies used. Therefore, we recommend researchers to adopt open science principles, especially those related to reporting their methodology and outcomes in a detailed way. For example, even in the used papers, sometimes it was difficult to understand basic components, such what was the simple unit. In this matter, Gerstner and colleagues published a great study called Will Your Paper Be Used in a Meta-analysis? And there, they provide a detailed framework with a step-by-step practice to publish a good paper that can be useful for future reviews. Here are the references that I used to create this presentation. I would like to thank CAPES for my PhD scholarship grant, and CNPq and ELAP for my exchange grants. Also, I would like to thank all the institutions that helped me in this journey.